Okay guys, today we are starting Unit 2, which is atoms in the periodic table. Big idea number 1, atoms are the building blocks of matter. So we're going to spend the next 2 weeks talking about atoms. Essential question 1 for today, how do I interpret data for each element on the periodic table? So we're going to talk about what the periodic table is and how we get information from it. So you have notes in front of you, they are guided, so you should be able to fill in the blank. Okay, so make sure that you have your periodic table notes out. They are guided. We will fill in the blanks as we go along. Okay? So, the very first blank there is a spot for a name, Dmitry Mendeleev. He created and published the periodic table in 1869. It's on the board if you don't know how to spell it. Dmitry Mendeleev, he created and published the periodic table in 1869. Now, the way the periodic table looked when he published it and the way it looks today are a little bit different. We've added to it significantly, but he is credited with completing and publishing the first version of the periodic table. We will talk quite a bit more about him and some of the other scientists.
I'm not finished.
Okay.
I'm sorry.
Hey, wait. Which book is this? What the right now?
Dmitry Mendeleev. His name goes right there. Okay, so what is the periodic table? The periodic table shows all known elements. All known elements in the universe. All known elements. All known elements is the next blank. And is organized by chemical properties and atomic mass. Is organized by chemical properties and atomic mass. Okay, so you're not writing anything yet, but I just want to talk about, here's how we're going to get our information from the periodic table. So our essential question, how do I interpret data? This is where that information is going to come from. So on your copy of the periodic table that I gave you, if you turn and look at that for a minute, you'll notice there's a number at the top of each box. That number is called the atomic number. Okay. Underneath that, you're going to see the symbol of whatever the element is. They all have a symbol. Then you're going to see the actual name of the element followed by the atomic mass or atomic weight. Okay? The atomic number is equal to the number of protons and the number of electrons. So the next 2 blanks on your paper, the atomic number is equal to the number of protons and the number of electrons. The number of protons and electrons are the same. The atomic number is equal to the number of protons and the number of electrons. Each element is going to have a symbol. It's going to be an abbreviation for its name. They don't all necessarily make sense. Okay. A lot of them do, like C for carbon, that makes sense. But like mercury is Hg. Okay. So some of them don't make sense. Some of them are like the Latin term or the different, terms for the names. So we'll talk about the abbreviations a little bit more. Okay. The atomic weight, or atomic mass, that you'll see at the bottom, is the sum of the protons and neutrons in the nucleus of the atom. It is also, and what I want you to write in your blank, the blank is the number of neutrons is equal to the atomic mass minus the atomic number. So, if you think about what the definition of the atomic mass is, it's the sum of the protons and neutrons. So if you subtract from that number the atomic number, which is the number of protons, then you get the number of neutrons. So the blank on your notes is the number of neutrons equals the atomic mass minus the atomic number.
What blank?
The second bullet, that one right there. Electrons should be up here, and this should be neutrons. No, that's right. Protons there. Yeah, I just add electrons right here. Yep, and then this is neutrons. Okay, so we're going to do an example really quick, which is what the big open spot is for at the bottom of your notes. We're going to do quite a few examples. Right now we're just going to do one. So make sure that you have your periodic table available, or you can just look at your notes. We're going to use carbon as our example, since it's the one that's right here. Okay, so carbon has an atomic number of what? What's carbon's atomic number? Atomic number is 6. Now, we know that the number of protons and the number of electrons is equal to our atomic number, right? So how many protons does carbon have? What's the atomic number? Yep, great, 6. The atomic number is equal to the number of protons and the number of electrons. So if we have 6 protons, how many electrons do we have? 6. Okay? So the number of protons and the number of electrons is equal to the atomic number. Okay? Now let's do another one. Take a look at your periodic table. Find oxygen. Everybody see oxygen? It's atomic number 8. Okay. Oxygen has atomic number of 8. So if its atomic number is 8, how many protons does oxygen have? 8. Okay? Atomic number, number of protons, number of electrons, it's all the same. So if we have 8 protons, how many electrons do we have? 8 again. Great. Now, we're going to add the number of neutrons this time. And in order to calculate the number of neutrons, you're going to take the atomic mass rounded to the nearest whole number. So if you look at your periodic table, the atomic mass of oxygen is 15.9994. Everybody see that? It's the atomic mass of oxygen. So we're going to round that to the nearest whole number. So what's the nearest whole number to 15.9994? 16, right? So we're going to take the atomic mass, which is 16, and we are going to subtract the atomic number, or the number of protons, right? So we're going to do 16 minus 8, which is 8. Now, do not assume that the number of protons, neutrons, and electrons is always the same, because it's not. Okay? Until we get into ions, the protons and electrons are always going to be the same. 8 protons, 8 electrons. But the number of neutrons is not always going to equal the number of protons and electrons. It does in this case, it does for carbon, it does a lot, it does for some of the smaller ones. But as the atoms get bigger, atomic numbers get bigger, number of neutrons is not always the same. Okay? So just be aware of that. Alright, turn your paper over to the back. Now we're going to spend some time talking a little bit more about well, this is just gosh, the bottom of that got cut off. This is just what we just talked about. Number of protons is kind of summarizing. Number of protons is the atomic number, number of electrons is the atomic number, and the neutrons is supposed to be atomic mass minus atomic number, but got cut off at the bottom. Oh. Just kidding. Okay, so we're going to talk a little bit more about elements, compounds, and mixtures, okay? So on the back at the top, an element is a substance that is composed of a single kind of atom. The blank at the top, single kind of atom. And it cannot be broken down into another substance by chemical or physical means. So atoms are as small as we get, okay, in terms of an element. And these pictures up here are showing you an example, like all of these are the same size, same color. Like this is one element. Now if you look at this picture, you'll see that there are two atoms. What this represents is we have elements that are called diatomic. It means they occur naturally in nature with two atoms of the same element. Okay? Hydrogen, oxygen, chlorine, fluorine, nitrogen, they all occur naturally with two. Okay, so this is still just one single element. Okay, there's just two atoms of it. Okay. Alright, so then after elements, we have compounds, which are the elements combining. So a compound is a substance in which two or more different elements, you'll notice it says different elements, right? In that the last picture I showed you, there were two atoms, but it was the same element. Now we've got two or more different elements that are chemically bonded together. So that blank on your notes is chemically. Remember, we've already talked about compounds a little bit in Unit 1, and we talked about how they occur in a certain ratio naturally. Okay, this is what this is talking about. So you'll notice here, this is, this picture would show like water, right, H2O. So one oxygen with two hydrogen atoms, okay? So this is a compound when they're combined like that. Then we have mixtures. So mixtures are two or more substances that are mixed together. They're just mixed together. They're put in the same container. But they are not chemically bonded. So notice the difference. Look back at your notes because I put those pictures on there for you. Notice the difference between the picture under compound and the picture under mixture. Do you guys see the difference? You see that the bonds, the chemical bonds, are not there in the picture under mixture? Right? So this shows that this is a mixture because it's got two different elements in it, or two different substances, but they're not chemically bonded together. Okay? So let's go through a couple more. So look at this picture. Element, compound, or mixture. This one's showing a mixture. They're two different substances, right? But they're not chemically bonded together. Element, compound, or mixture?
Compound.
These are compounds. There's two different elements, but you see where the bond is? That little line represents a bond, right? So they're chemically bonded together. Good. Element, compound, or mixture?
Element. Mixture.
It is a mixture because it's a mixture of an element and a compound, right? You've got compounds here. Purple is a single element, but they are mixed together. So this is a mixture. Okay, good. Whoops. Element, compound, or mixture?
Element.
This is an element. It's just one single type of atom. Element, compound, or mixture?
Mixture.
This is a mixture too. It's a mixture of two compounds, right? Because this is a one compound and this is a different compound. They are mixed together. Good. think this is the last one.
Compound.
Be careful on this one.
Element.
This one's that element from the beginning. Now it looks like a compound, right? Because there's a
Chemical bond.
bond there, right? But this is just a single element because these are the same atom. Okay? In chemistry, we call it Brinkelhoff to help us remember which ones occur diatomically, but it's the so bromine, iodine, nitrogen, chlorine, oxygen, hydrogen, oxygen, and chlorine. Okay? They occur diatomically. Two, di meaning two, and then atomic meaning two atoms. Okay? Okay, so at the bottom, this is where we kind of move in a little bit to essential question 2, and I hate to really combine them, but I do think it's important for you to identify these first. Mixed. So I don't like to typically do 2 essential questions in one day, but I do think it's important for you to go ahead and define these, and we're going to talk more about them tomorrow. But protons have a positive charge, so in your parentheses on your notes, put a little plus sign. They are positively charged particles found in the nucleus. Neutrons have no charge. They are also found in the nucleus. And electrons are negatively charged particles that orbit the nucleus. Then I asked a question at the bottom, which one of the subatomic particles is the smallest? It's electrons by far. Now tomorrow we're going to talk quite a bit more about AMUs, which are atomic mass units. It's the way that we find mass of atoms because they're so very small. The atomic mass of a proton is considered 1. The atomic mass of a neutron is also considered about 1. We're rounding, but about 1. The atomic mass unit of an electron is 0.005. Okay? So, significantly smaller than these. Oh, 3 zeros, sorry. I wrote that really funny. So even smaller. Okay, 0.0005. Okay, so this is how much smaller electrons are than protons and neutrons. So when you look at the atomic mass of an element on the periodic table, most of the mass is coming from the nucleus, right? Protons and neutrons. Okay. Everybody got? Anybody still need this page up? Okay, so here's what I want you to do. Back on the front in that white open area, we already did the first one here. We found the protons, electrons, and neutrons of oxygen. We did that one already over here. So I want you to find the protons, neutrons, and electrons of xenon, which is Xe on your periodic table. And then I want you to find the number of protons, electrons, and neutrons of zirconium, which is Zr, on the periodic table. So you're going to have to find them first. Remember that your atomic number is your number of protons and electrons, and then you're going to have to subtract atomic mass minus your atomic number to find the number of neutrons. So go ahead and take just a couple minutes to do that. start with number 2.
Oh,
We did oxygen earlier on the board over there.
huh?
Now guys, you want to round whatever the atomic mass is, you want to round it to the nearest whole number and then subtract. Okay, you're not going to have, part of a proton or part of a neutron. Make sure you round it first.
Oh, I see. I mean, 2 in minus in.
Oh, so you find the number of protons, electrons, neutrons.
So how do I do that?
So, okay, so number 2 is xenon, right? So that's over here. The top number is the number of protons and electrons.
Oh, this one.
And then 131 minus 54 is your number of neutrons.
What do you take on?
Well, you just round it to the nearest whole number. Okay, so guys, for xenon, remember that the number of protons and electrons is equal to the atomic number. Those are always going to be the same. So your atomic number for xenon is 54. So you have 54 protons, 54 electrons. Now, for neutrons, you've got to look at the atomic mass, which was 131.2 something, 24, I think. You're going to round it to the nearest whole number, so 131. Then you're going to subtract the 54, and you get 77. Questions on that one? And then for zirconium, the atomic number for zirconium is 40. So you should have 40 protons and 40 electrons because they're going to be the same. And then your atomic mass of zirconium is 91. So you're going to do 91 minus 40, and you get 51. So our essential question, how do I interpret data for each element on the periodic table? So for each element, we're given an atomic number, which tells us the number of protons and electrons, We're also given an atomic mass, which is the number of protons and neutrons added together, so we can subtract to find the number of neutrons. Okay? Questions on the data that we received from the periodic table?